G'day guys, this is the GPZ-7000 that I replaced the capacitor in yesterday, and I got a battery. I had another GPZ which was out there. I didn't realise had a battery, so it had a battery and I've just borrowed the battery off that and stuck it on this one. And there's that bigger 10,000 microfarad capacitor sitting in the circuit, happy as Larry. And when I told the fellow that his detector was all fixed up, he now wants me to do full modification on it. So he must have seen the video and said, well, this guy might know what he's doing. So a full modification. Thing is, I've got the coil sitting in the bin. It's sitting in a plastic bin at the moment. And when I move the metal chair, it's detecting me. So that is the detector. Oops, this has become loose on the tripod, whatever. That's me moving on the chair. And I don't know if you can hear that. I've just got the speaker plugged into the detector. So if you can hear that, I'll just get a screwdriver and whack it near the coil. Yeah, so it's working quite well. It's working very, very well. And starting on these modifications, the first thing what I've done, and it's what MindLab has suddenly, or shouldn't say suddenly, it's what they've been doing to the 6000s, but I've been doing it for years anyway. And I'll just turn this thing off. Yep. So yeah, I've just got it on this GME speaker at the moment. Works fine. But what I started doing, because it's going to get fully upgraded, you see all in there, it's all carbon black, the whole lot. So that is now been treated, and that'll cut down a lot of stray field interactions, anything leaking from the board that could generate a bit of a field and couple in somewhere else. Well, it's going to go through 5 ohms of carbon now, so it's not going to go very far. It does help. It also helps a little bit with electric fields, stray electric fields, and basically gives the whole thing a proper grounding. So it does reduce the noise. And the other thing I've got to do in here, and I should point some other stuff out, because if you guys are watching these videos and you do want to know a few things here, I'll show you a few things. I might as well do it on this one because it's going to get the works done as well. And the works continues to increase as to what we can do as we get right into it. So I'll just get the battery off. Round you go. So we'll take the battery off and we'll make it all nice and safe. But what I'll do, I'll show you something that you can do to these detectors. And this was for our friend Adam. He's had a lot of stuff done by us. And I was just going to show him, I was going to get the meter here and just double check a few things. On the battery, we know when we look at this bit here, we know, or we should know, well, probably people don't know, but I do, that the big thick lines here, big thick ones, the two here, is battery positive and negative. The rest is just data and whatever else. But all we got to know is which ones of those is negative and positive. So I should have left the battery in, but what we'll do, I will just get the meter. And I'm pretty sure I remember, but I want to just prove it out. So we're getting the last two here. in the battery, and the far right one is positive, and the far, not the far, but the one next to it, should I say, is negative. So that aligns with those two Mylar. The one here on this side is the positive, the one next to it is the negative. So I might as well do this with the shielding material. I'll show you what I do. Let's make sure that I have my brush here, because I don't really want to start on something. When I use the carbon paint, it dries really quickly and you've got to be onto it. So I'll turn that off. I know I left it somewhere very nice to dry, and might be out. Hang on a sec. I'll just check. It's just out the door, I think. So out here I go, and I have walked off with it. I must have left it out there, and I've come. Oh, there it is. I put it in a safe place, up on this shelf hanging over. So come here. All I use is this little brush, that brush, little paint brush, and yeah, no matter how much you wash it, you'll never get all the black out of it. It'll be black forever onwards. So I'll just put that over there. But this is for this. This is what I think you could do to fix that reset problem. So you get this horrible black stuff. Shake it up. Put it down. Don't hold it in your hand. If you drop it and the black stuff goes everywhere, you'll kick yourself. Right? But what I do this. And I've learned that I'm going to do things very quickly. So turn the lid upside down. That's the paint you're going to use. It's in the lid. Get the rest of it. Put it up away from anything. No one can knock it over now, because you're going to use the lid as like a little paint holder. But what you do here, okay, say you want to shield this. So I can just get a bit of paint on the brush, wiggle it around a bit, because the brush was, I was rushed out the door. I didn't clean it properly, and it's a little bit iffy, but no, it's coming good. It's coming good. What you do, you can paint this like I'm doing now. Just don't get near those silver or gold flashed contacts, and just paint the whole Mylar over the data lines, over the power lines, like I'm doing. Because this thing can radiate. It just can. I know it can, and it can be act like an antenna as well. It won't hurt anything, because everything is sealed in Mylar, and Mylar is an insulator. And basically, I've just made the whole thing black. You want to get a little bit more complex and technical, you can do this line here, which goes to that Bluetooth transmitter and audio, whatever else is there, whatever else that goes to. So I just paint that down. You only need to do one side. You don't need to do both sides. It's not that critical. Just don't touch any of the connections on the top or the bottom. So if you have a look at that, if I can hold it, you see the top where I stopped the paint doesn't go near any of those conductive fingers. And on the bottom, it doesn't go down and touch those where the pins are soldered through. You don't want to put carbon across that. Like I said, you'll make a carbon arc lamp in your detector, and it won't be very good. But what we know for sure, I'll just touch this myself, get down a bit more. We know the second one along, the second thick one, is our negative. So what you want to do, very carefully, of course, and if you balls it up, you want to, just wash it off. I should be using my 4 eyes doing this, but I can see it all right. Just do it down there. As long as you don't touch anything conductive, it's fine. Now, this brush I classify as dangerous, so I think if it falls, it'll put black paint everywhere. But if I hold that there, close, I hope it doesn't go out of focus. But you see, I've just painted down onto the negative connection. So now that whole strip is covered with a negative connected ground plane shielding. So you just let it dry, it air dries. Just make sure you don't get any on the end on those fingers. So this is something you could do to your detector as a preventative measure for possibly, I'm saying possibly, I haven't proven it. Um, you know, I can go and hook up a signal generator and stuff and, you know, point a little small little antenna thing at this or whatever and turn it on, see if I can make the thing reset and see if it does or doesn't after this. But you know, that's neither here nor there. It either will improve things, and if it doesn't improve things, it has no bearing on the whole operation of the detector. It should improve um, anything to do with interception of radio waves or any sort of electromagnetics. It should have some sort of effect. It's basically carbon shielding. Um, that's it. So I just let that dry, and it's very simple to do. When it's dry, I can put the multimeter on there and test it around. It'll be a couple of ohms or something around. So that's that. Now I've got to get this lid and put it back on the bottle. So I'll stand up and do that. I won't muck around because if I muck around, it'll go pear-shaped. The other thing too, because I've dipped my brush uh, in that paint, it will dry, and that'll be the end. If it dries, it's the end of this. It won't work ever again. So yeah. So the rest of the upgrades on this thing, I've got to get right into it again and basically do more to it and see how I go. But yeah, I'm just looking around to see if I haven't got a spare container. If I had a spare container, I could grab some water out of my bottle here, which I use for my soldering station, and stick this in it just to loosen up the paint because I don't really want to walk off to the sink in the middle of making a video just to wash the paintbrush. And yeah, I don't know if I've got any sacrificial containers. I'll tell you what I do have though. I have that sacrificial rag. So I'll just use the sacrificial rag. It's got so much stuff like silicon on it that oops, the water won't even soak in. So you know, if you wet it up like that, you know, God, that stuff it is just um, so damn potent. You know, a little dab of this black paint in a bathtub of water will turn it all black. It's just really, really thick and strong, dense. Dense is probably the best word. But yeah, if I just do that and get a bit of, look, you know, it just goes to carbon everywhere. Look, you know, turn the whole thing to carbon just with a little bit on the end. So yeah, and it'll bleed through and get on my fingers, and I'll be conductive. Um, Crazy, isn't it? But yeah, that's how this stuff works. I will have to clean that. I'll just leave that there. Don't touch anything. So yeah, like I say, this is a sacrificial rag. Um, Even a bit of water on it probably may come off, may not. Don't know. Now, well, I've been yabbering. There was something else I was going to say about this, and I bloody well, it's just yeah, fallen out of my head because I went and did that. I was going, what else I was going to do something, and I said you can do this. So yeah, I've done that, and that's come along quite nicely. That's a simple thing anyway. Um, oh yes. Okay, I have a little trick that any of you guys who have these detectors. I'll just unscrew it all so I can pick up the board. Okay, there goes the coil connector. That can go in the bin. Not really, but it's just where I'm putting it with the coil. Okay, and we'll undo the connector on the head unit. Okay. This little wire, and I say little because it is pretty small, but luckily we're talking very low frequencies with these detectors within reason. Yeah, because very small cables tend to have large losses as the frequency goes up. But anyway, not going to worry about that. With this, you can see here on the module, the receive module, the receive wires down the board here. It goes through these little clamp clips, little plastic one, there, another one down there, and then it goes off wherever it wants to go off to. Now, where this thing is routed, and I've actually proven this to myself, and you could do this. This goes around that way, that little plastic clip there, which the wire's out of, that one there, right next to the red capacitor. That sits in there, and it's between those capacitors, and it routes itself on between the power output stage and the big capacitor I stuck on there. Now, what I would do, because and relatively too, you just got to think this out. And I've done this, and I have had a bit of success. Where it clips in here, I take it out of this clip, take the wire out, and what I do, I route it over here. I route it on this side, the other side of the capacitor, and I stick it back in there like so. And if you really wanted to, you could probably put a dab of hot melt there to hold it. Not that it's absolutely necessary. And you want to, normally you would put this fairly close to the board, but around this area here, we've got switching power supplies, right? And here you have basically the transmit generator. And it's what I would call, we always try to keep the receiver componentry away from the transmitter. It's just good practice. And I personally, I don't think it's going to make a huge difference. But I don't like that near the power stage because it's a receive input wire. And I just stick it over there. I stick it on that side of the capacitor. I do not put it down near the bottom of the board like that. The reason being is that here there's a very noisy, well, it's not noisy in conventional talk, but I'm saying there is a lot of stray field from this core here, and you don't want this sort of in the plane of that at all. I just stick it up away from the board, and I've got the hot melt glue on the gun. So what I'll do with that, I would have it like so, and I would, remember I said about getting the heat into the components, you're trying to stick. Don't just go dab dab, it'll probably fall off. And down here, I would just got hot melt glue on my thumb because I'm trying to hold this and push it at the same time. On the top of those two capacitors there, I would hot melt to those like so. It is near one of those polypropylene capacitors that it's on the far end of it. It's not going to make any damn difference. But just the way I've done stuff in the past, I would do it like, I don't know if you can see very well, because I've got the light that way. Hang on. How about that? you can see I've just stuck it there on the capacitor. Okay. Now I've measured this with a probe on the wire, and there's less stray fields or induction currents on the outside braid. Even though it's on the outside braid, this module is very, very sensitive, and you know, it's, to me it's just good practice. It you know You'd really want to, like, say as an idea, I'll use these, and that's a dangerous end. You put paint everywhere. It was up to me. I would move. If you have a look under here, these inductors, they're the transformer and inductor. I would move these way over on the side of the board. Plenty of real estate to do that. A little bit of an artwork change to the design, and then I'd pull some of this other stuff. Even the power components here have a full ground plane, or a part of the ground plane full copper here. Lots of through plating and eyelets to keep a low impedance. Part of the board. I would stick the wire down on that, and then I'd go up and wherever it goes. That's just me though, and like I say, I didn't design this board. It is functional. It does work, and yeah, it's just that there's a lot of dead real estate here, whereas you could have moved those noisy things to the edge of the board, and yeah, it would have been a little bit better of a design, if you ask me. That's my opinion. I'm not saying that it's a cock-up design or anything like that. It's not. It's just that I would have done things differently. I would have really just made sure that all the power stage, well, most of it is, it's all over in the corner, and you know things like noisy power supplies. Well, you can see it in the design of the 6000. They've shoved all their noisy power supplies way away from their front end. So the front end stuff is all up this end of the board, and all the noisy stuff is parked down the far end of the board. Just because you can get field induction through various tracks and things, and you know it should be checked. It should be looked at. You can model it on software if you really wanted to, but I never trust that. It is not 100% real world. Just a slight wire placement, a different spot, can cause different things to happen. But yeah, that's how I would do it anyway. And you might be saying, oh, but that wire's down near the ground plane. Well, it was sort of for a reason. Well, yeah, well, there's that same wire here, and it's nowhere near the ground plane. It goes up in the air. It goes into the connector. So, you know, that's a null argument there. You could actually go and get it and just move the whole thing away from the board. But as soon as you do that, it wants to act as an antenna. It becomes a high impedance. The braid becomes a sort of quasi high impedance pickup line. And if you've got it squashed down near a ground plane, it lowers the impedance. It's less likely to pick stuff up. So it's if you really wanted to, you can um, put a triple layer shielded cable there, and have it grounded here, and then run the other one up here, leave the braid off here, then you connect the braid to the metal end of the plug here, which you can't see because I'm looking at what I'm doing and not at the camera. There we go. You can connect it onto this wire here, and run a double braid system, where one braid is to the board, the other one is to a far connector, and you just don't connect the two together. It gives more isolation, and the only cross coupling you're going to get by doing that is both ends are grounded, but you got a little bit of extra capacitance there between the two braids, but it will protect the inner conductor to a greater extent anyway. There's different ways of doing grounding techniques on all this stuff. Maybe here you don't want to ground it, and you want to ground it elsewhere, but convention, normal thinking, yeah, it's a signal input wire, ground it close to where the input is going into your receiver module, and yeah, just ground it at the other end. But then again, big long wires do pick up stuff, um, even if they are shielded, unless you're going to go to a fully differential system, and that gets, in something like that, might be a little bit too difficult. But I'm probably starting to talk crazy technical stuff, and no one will know what I'm talking about. Few people will, most people won't. So sorry about that. But yeah, that's a simple one you can do there. A simple one you can do is you can increase the value of that capacitor, which I say is a critical component in keeping the transmitter stable. As far as I had to look up, actually, I finally decided to have a look up on the whole design of this as much as I could, and I yeah, I got the gist of it. I got the gist of most of how it works. It's just it's very much like it's very much like the other detectors, except it does have differences in the way it transmits because it's a bipolar transmit system. And I think I measured the transmit pulses too. They weren't very long. They're only around about 5.5, or 5.2 microseconds on each transition, which is very short indeed. So my conventional thinking would be, how are you going to? I'll probably cop flack over this, but I'll say it's my opinion, right? And I'd love someone to tell me that you get a particular size target, nugget, target, whatever, and to fully energize it, you need to put a lot of energy into it. You've got to do it over a long time period. You know, if you want to charge up something the size of this, you know, it's not going to do it in 5 microseconds. It's not going to do it. It's going to partially charge it. So um, I don't understand, because in our conventional other detectors, right, you got pulses. Um, you can look at them and you say, well, they're 35 microseconds, right, in the other older GPXs and whatnot, and this thing's 5 each way. But 5 is 5. Then it changes polarity. So yeah, I haven't got my head around that, how it energizes large targets at depth. Maybe it just does it so fast that it's a ramping effect uh, or something. I don't know. Like, you know, you got to put a bucket of water in before half a bucket comes out. You got to throw another one in, or something like that. I don't know. I really don't know. But it seems to work. It seems to work quite well. So there is something about the bipolar pulse having a good enough effect on big deep targets to light them up as well. So, you know, because you're running a short pulse, you can receive a lot quicker. Well, not a lot quicker, but you know, it's only a short pulse. You receive the signal, then it's then flips transmit, goes again, receives. So there's in a given time, there's a lot more samples. So if you've got a time period and you say, oh, you're running 35 microseconds, and you got your ground balance one, which is 120 or something, 120 microseconds. Well, this is doing it all in little five odd microsecond bursts. So it shows that there's a lot more sampling going on. Thus, that's how I would say it is picking up the deeper targets. There's nothing written up about that I can find online that tells you how it works. It's basically the only thing I can find is how it flips phase, and it's meant to cancel some artifacts that the other detectors don't do so well. But anyway, that's that. We have fixed the initial problem, and now I've got to get in there and do all the rest of the modifications to it. And that is going to be very time consuming and very, very fiddly and very, very critical. And I'm not going to make a video of doing that because um, I think possibly people will try and emulate that. And if you do that, you might get into a bit of bother and destroy your detector. I'm only pointing out really simple things, really simple. Even doing that capacitor, to me, I mean, it's simple, but it's also difficult. It's You've got to plan it and have the right equipment to do it. Um, and don't cook all the other components around it when you do it. It's just, to me, it's obvious. It may not be obvious to everybody. So if you don't want to do it, don't do it. It's probably better if you don't do it. But if you want these 7000s to be quietened down and upgraded, which we've done quite a lot of them now, and also the sixes. So there's nothing that we can't improve. It's a matter of just how far you want to go. Like the old saying in the industry is that when you're building something, you're designing. Say you had the guy at Coda and MindLab, or guys, whoever. I don't know if it was a team or one just sat there and built the whole thing. I don't know. Right? I say there's all this I don't know. I wasn't there. Don't know. Right? And he makes it, and he's building away, and he's working away, and he's sitting there and he goes, well, I've got a functioning detector. How about, if I do this, this will improve this. And, now that I've done that, that will work better if I do this. Now, this is what um, design engineers are known for. They keep engineering. They want to have their little pet baby project as good as they can get it. But the management are sitting there saying, come on, we need the product out the door now. Garrett's releasing a new detector in 2 months and we're behind the eight ball, or whatever else. We want to get in before the Easter rush or Christmas rush. And the engineer will be going, no, look, and the management will say, well, this is true because I've experienced this. Management will say, does it work? And the guy will go, the engineer will go, yeah, it works really good. Stop. Give us the final layout and we'll go get it made. And they have a saying, it's called shoot the engineer, right? Because the engineer doesn't stop. Because, I could say that what I'm doing is improving the performance of this. And I'm probably like the engineer. I'm saying, well, I've got it this good. I can make it better and better. So, you know, my opinion is MindLab goes, oh, stop that. If you have a look at these boards, there's provision for a hell of a lot of other components. I could go point them all out, but there's little surface mount capacitors missing. Well, not missing. They just haven't been designed in. Have a look here. Now this will really yeah, screw with your head a bit, right? But look here on this board. I don't know if you can see it very well. Look here, the amount of componentry. All the pads are there. There's no components, but all the setup is there to put lots and lots of surface mount components there. And there's also a connector here. So what's all that about? I look at that and go, well, it was going to have something else connected in there or whatever. And it's not. Here, look here. There is a provision. What I can see the outline for is a surface mount dip switch. It has a switch symbol on it, and that's not there either. Could you have set up different modes on the board? These are the things I have no clue about. No idea. I don't know what the idea was to do that. So, you go, okay, we'll have a look here. What have we got? A lot of it's very, very similar. You look here, you got your um, multiplexes along here. There's an A to D converter there, so a lot of it's analog to digital conversion. That chip there is the brains of it all. It's a very, 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 very clever chip. And because it's a BGA, the poor Chinese would not be able to get in there and copy it. I don't think they would anyway. They probably want to, but I don't think they can. But yeah, even here, there's a little symbol for a surface mount trim pot. It's not there either, but it obviously doesn't need it, because otherwise it wouldn't work. But what else was going to be put into this that's not there. You could, it's obvious to me. You don't put a whole heap of solder pads in there and have the the screen print around it indicating there's components going on there. Like, there's even a SOIC component there. It's not there. So what was that? It'd be good to know. Is this the Model 2? You put the extra bits on and you got Model 2 or something. That again, I don't know. I don't know why. Or was it stuff going in and they said, stop, we need to get it to market? Um, that's a long shot, but you know, possibly, possibly not. I don't know. But yeah, looking here, you can see here there's provision for something on this side of the board there. 4 pads, nothing there. Next to that inductor is a provision for a surface mount capacitor, not installed. Um, yeah, if I put my 4 eyes on, I'll be able to pick out a lot more. But this is the story with this stuff. Yeah, it's got provision for stuff. It's just not there. Um, See, that just makes me want to look. I'm going to have a good look at this because I think there is some stuff there. Yeah, yep. There's another chip component. It's not installed. Don't know what it's for. What it was going to do. Um, you know, even you look here. I don't know if you can see the tip of my finger. There's a surface mount resistor or something that was meant to go in there. It's not there. You can see the pads for it. Another one there. Um, Obviously, well, I just don't know. I don't know. You really need to have a look at the whole circuit. Here, another one here. R412, not installed. Yeah. So yeah, R1 up here near the module, not installed, but the provision for it. So they could be. I don't know. I really do not know. Yeah, it's actually a few parts around. Here we go. R495, not installed. Uh, R449, not installed. Yeah, but the one that gets me is on this side of the board here, where you have U1002, not installed. And you go along here and you go, well, C215, not installed. U205, not installed. Um, and all these little pads here, whatever. D201, C203, not installed. 28 pin connector for something, not installed. J501, not installed. Um, yeah, test points. Switch 501, not installed. You know, you really would love to go and bridge each one of those out and see what changed. Maybe it's not a good idea. I wouldn't do it with someone else's detector. I don't think I'd even do it with mine because that's Pandora's box. You know what happens? You can see here that where this switch is, there's a miniature crystal oscillator there, and it goes in that area. So yeah, I don't know. I really don't know. So it's very complex. If you didn't have the full schematic for it, which I think is locked up in a bank vault, if you ask me, from previous happenings, um, that no one will know except very, very few, very, very well trusted people within the company would know um, about all of the circuit. But by looking at it, you can work out a lot of it um, just by looking at the parts, what they are, where they are, you know, because they protected it with these ball grid array type chips. No one will ever work out the function. Well, you could, but my God, what a headache. Yeah, but like I say, it's having a look at it, how it all works. You know, it, it works. It works. The thing, my pet hate with all this stuff is this business here. Uh, let's lock the front end up so we can't do any improvements to the front end. Um, that's just sad. But you can if you want. Yeah. I've gone along all the pinouts here and looked at what's happening, and it can be gotten around. You put your whole new module in there if you wanted to, but God, what a time-consuming thing to design. And because of all the pins on this thing, it's all pinned all the way around into the ground plane. And you know how hard it was. I'll take these off because I'm going cockeyed. You know how hard it was just to do that ground leg on that capacitor. Imagine doing something like 30 legs on this all at the same time, trying to get it off. The only way to get around the module would be to get a Dremel in there, cut all the legs all the way around, right? Drop it off, and then put your own circuitry or a submodule in that you can actually get in there and do things with. It's only a front end. It'll probably have switching for transmit, receive, timing, and all sorts of stuff in there. But you can nut it all out. You've got the control pins here anyway. You can just make up your own components to do the same job. Just, any switching, you can nut that out. It's not that difficult. You just got to know where signal goes in and basically where it squirts out and what happened to it in the meantime. And you can go and measure all those pins. Most of the pins here are ground pins. They've tried to make it a little bit interesting by putting some extra. It's probably got damp. It's some sort of. It's not really damping. You don't have damping as such in this design. But yeah, you could if you gave me 3 months and didn't disturb me, I would have that nutted out, no problem whatsoever. But yeah, I'm lucky to get 3 hours undisturbed. So I think the design is safe. Yeah, anyway, rather than waffle on about GPZ-7000s, 7000s, that's the way I keep the Americans happy, rather than say, a GPZ, which most of um, the English-speaking world say, and they want to say Z. I don't know why the disparity, but I say ZZ, ZZ. So I might change the letter Z or Z to ZZ and get all the schools to do it too. What do you think? I don't know. But yeah, well, I suppose, I don't know. You know, yeah, interesting. And by the way, these two capacitors, here's your plus or minus 5 volt power supply that goes into that module. You could even put bigger caps on there if you wanted to. You probably don't need to. You could even go and put some, couple of very low ohm resistors on the supply rails into those caps to clean up the rails. Yeah, a bit more or something. I don't know. There's a lot of things you can do, but it's the designs like this when they become modularized or modularized. Is that a word? Or modules make it very, very difficult to work on. Um, you really, for anyone just wanting to muck around, if you like I say, you could actually go and dip this in some evil chemicals and chew it all the way down to its silicon structures and analyze what it all is and rebuild it and do it your own way and do it open so you can work on it. Maybe it's just got um, you know one particular transistor or op amp or whatever as a front end. Maybe you want to do a parallel transistor input stage to get the noise down. And but I'll tell you something. I actually did try putting a preamp in front of this, and it has some. They're smart. There's some detection in here that if you try and do it, it senses it and will not work. So you can't go and put an outboard preamp on it. The only thing you can do, which I did, which is totally pointless. But I just used a low noise op amp as a buffer. Okay, so I didn't have any reference to the non-inverting input except the output from that, and I stuck that there and it did work. So it has something, and you pull that any which way to ground, it just won't work. So I just wanted to get a really, really low noise input stage of about 3 dB gain. Maybe it's probably, if you make it less than that, it's probably not going to do anything. It's not going to be worthwhile. And you really want a gain of probably 10, and then you can make a really low noise stage. And possibly you could, calm it all down by really stepping up the input gain of a separate circuit, and then uh, just putting a T network of resistors into the input of that. But that's probably pedantic and horrible and not the way to go. I'd rather make something from scratch where I don't have to use their input stage and just make my own and then have it go to where it's meant to go. That's what I've been doing for years. So as soon as I do that, it really limits anything you can do on the receiver. It just uh, yeah, it is stops you. What you could do if you really wanted to, you can get this cable here and chop the whole cable out, the whole thing all the way to the connector, and put a thicker one in there, right? Um, yeah, so you can see the insulation on that. I don't know. I don't think it's air spun polyprop or anything like that. I think it's just standard cable. It could be Teflon. Uh, I think it might be Teflon, but you could put a small air-spaced piece of coax in here, and if you really wanted to, you could probably get the. I'll tell you what you could do. Um, you could destroy a double D coil and get the receive cable. Not that you don't need the transmit side, just the receive because it's got a spiral braid, and you could just measure that out and utilize the cable with a spiral braid all the way down. And maybe because this is a silvered by look of it or tinned braided cable, but this works on a different principle. I don't know if it would um, cause an issue like on a standard detector. I don't know that. It could be an experiment to get some miniature um, braided, or that spiral braided cable off a double D type coil, spiral serving they call it, and just basically rewire it. Will it make a difference? Well, if you do everything and it makes 1/4% difference, and you do 100 things, well, it's 25% better, isn't it? Or something, not that 12.5% better. But every little bit helps, especially when you're looking for deep gold and tiny gold that's hard to hear. You clean these up as much as you can, and you could possibly have a performance increase. I do say possibly because I don't like saying on someone's design you will, and it's going to happen, and it's because I would hate someone to do that to me, so I don't really want to do it. But like I say, that's what I was given the example: shoot the bloody engineer to get the thing out the door, and maybe that did happen, maybe it didn't. Who knows? Um, Maybe the engineers, you know, only schooled in a particular, um, you know, section of electronic design and not over here and not over there and doesn't know about this or does. Like um, early on in the early days of Mindlab, I got told that not one engineer knew the whole board or the whole way it worked. It was all done by one guy did this, one guy did that, one guy did this, and one guy did this over here, and it was all stitched together with level translators, which wouldn't surprise me in some of the designs, in my opinion, because I know if I say that, people get their nose out of joint. But um, you know, people that worked at the company told me this, so you know, why would they tell me fibs? They might, I don't know, don't think so. But Very interesting. And by the way, I've heard on the grapevine, Garrett are putting out a new detector. I don't know what it is. Garrett are putting out a new detector. Um, I don't know if it's a PI or it's a coin machine or what it is. I don't know. So keep an eye out for Garrett's new machine. And if you know what it is, please leave it in the comments and tell me about it because I don't know. I just heard off a few people. Yeah. Anyway, David's back here. He's I can hear him opening the door. No, it's not David. It's Chari. Okay. Good stuff. Anyway, it's enough waffle. I'm going to have my dinner. Catch you.